Pacific Northwest. There's a climb that goes from about 10% admixture in the southeast to 50% in the northeast as far as admixture of Caucasian genes. There's an interesting problem with modern Jews going today. If you look at the demographic studies that have been done on marriage patterns in modern Jews, over the last 50 years, for example, modern Jews have experienced probably somewhere between 10 and 50% gene flow. That means that between 10 and 50% of a person who claimed to be a Jew married outside of Jewishness. Okay? And so it causes some real problems for identifying an origin population from which to make comparisons. If you look at this chart, you can get an idea of how much the percentage of the residual genotype that we would expect. And this is just strictly from the mathematics involved in the situation. But if you look over here at the number of generations or the number of years that have passed, what are we talking about since the time that Lehi was here in the Americas? We're talking probably 2,000 years, maybe 80 generations down here on the bottom. And so what percentage of the residual genotype would we expect in a population if they were equal to start with? Okay? And that's a huge assumption, which we know is false, because it wasn't equal to start with. But the residual genotype, if we have admixture or gene flow per generation of say 5%, that means 5 out of 100 of the Nephites went over to the other side, okay, which is probably reasonable, probably much more than that at certain times. Then that means that in 80 generations, we should only expect to see 1.7% of the residual genotype in any population. Have there been any genetic studies done yet that would be able to identify that residual genotype? And the answer is no. It's not. There have not been. So, okay. So, what does the current data say? Current data says that if you look at the mitochondrial DNA in Native Americans, and it's a good sample, it's not the best sampling, but it's a good sampling of the populations of the Americas. Okay, it's spotty, but not bad. It shows that there are 5 major haplogroups: A, B, C, D, and X. All of these haplogroups have their origins most probably in Asia. Okay, so the mitochondrial DNAs that we find in Native Americans came from Asia, including the X. And this is an interesting story in coming to conclusions too fast, because when the first mitochondrial data came out, there was A, B, C, and D. There were strong arguments as to whether or not that represented a single migration, whether represented 3 migrations, 4 migrations, 10 migrations of people from Asia into the Americas. And you also have to remember the time frame that we're dealing with here. We're talking tens of thousands of years ago. Okay? It has nothing to do with what we would expect to see with the Lehites. Okay? So, then all of a sudden X showed up. And in all of the population studies that had been done in Asia, no one had ever seen an X. And so they looked around to other places in the world, and guess what? They found X. They found X in Finland. They found X in Turkey. They found X in other parts of the Mediterranean, including Israel. Okay, so guess, what did we see? We saw a whole lot of people jump right on top of that and say, aha, there are the Nephites. But they forgot to look at the rest of the data that said that that X entered the Americas probably, 15,000 years ago. Okay? And now it turns out that just within the last 6 months, the X haplotype has been found in Asia, okay, in another group in southern Siberia. And so it's likely that the X also is an Asian mitochondrial haplotype. Okay? And so we have to... I don't think there's any way around that evidence. I think even in sampling every population of the Americas, we will still see that the vast majority are A, B, C, D, or X. Will there be others? The answer is yes. Have we seen others? The answer is yes. Okay. Do we know where those others came from? No. We don't know that yet. Do we know the date of entry into the Americas yet of those others? And some we have a guesstimate, others we don't have any idea because the numbers are still too few. So, Y chromosome data. There's one major Native American haplotype that has been identified. The problem with it is that not all Native American males have that haplotype. Okay? In some populations it's less than 30%. In some populations it's greater than 90%. But it is certainly a Native American marker. Is it the only Native American marker on the Y chromosome? The answer is no, it's not. There are other true Native Americans that do not have this particular DYS199T haplotype on the Y chromosome. Is there more to be found out? Yes. Okay, what about the Cohen modal haplotype? You know about that, right? The Jewish connection to South Africa and the Lemba tribe. I'm out of time. I just was told right there. And that's actually a whole other talk. But the idea is that, first of all, just the take home is that the media reports and the things that we see out in the press, that this is a Jewish marker, are overrated. Because there are lots of true, real Jews who don't have the Cohen modal haplotype. This is a very specific type within a group of Jews that have this particular. Is this a Jewish marker? Yes, it is. Is it the only Jewish marker out there? No, it's not. Okay? And has it ever been found in the Americas? Yes, it has. Okay? Does it have any relevance to Nephi? Probably not. Okay? But last December, it was reported in the genetics literature that the Cohen modal haplotype has been found in Colombia. And however, they attribute it to Spanish admixture, Spanish Jews, okay, that left Jerusalem, went to Spain, and then came to America. And that hypothesis is perfectly fine, and there are ways to test that. That hypothesis has not been completely tested yet. But it's a pretty reasonable explanation of the data as it stands right now. Okay. Autosomal, this is where I think we're really lacking as far as the genetics evidence of determining the origins of Native Americans, and that is that there's almost nothing out there. There may be 12 or so loci in very small populations, and some of the markers that are studied in one population have not been studied in other populations, and there's a real need for a larger study that has to do with those. And if you take all of the Native Americans that have been studied to date, probably less than 5,000. Okay? And I'm being real generous here in identifying 75 populations. There are over 500 recognized tribal groups in North America alone. Okay? And so has all of the research been exhausted, and are we finished, and are we ready to make conclusions? I think the answer is no. Reasons for erroneous conclusions, I think, are impatience and anxiety, or anxiousness. We want to have the answer, we want to have the answer now. And so we'll take the answer even if it's the wrong one. Okay? And so I think we have to be very careful. I think there's a general lack of understanding of genetic mechanisms, and this was outlined to me graphically in the last 2 years by a person out there who's written extensively on the internet, who claims to be a molecular biologist, who is not. Okay? And he does not understand population genetics, as was borne out in my personal communications with him. Incomplete data, we talked about that. Both anthropological, as far as population dynamics, the effective population sizes that we've dealt with, those are absolutely critical for understanding the genetic data. What about disease? The genetic data is still